Hi class, this is Miss Disney here. Today we're going to work on balancing chemical equations. So this is really important. We haven't talked much about chemical equations, but this is how it starts out. So we have the reactants, this is just an example here, but we have the reactants on the left side and the products on the right side. That's always true for any reaction. And then in the middle, we have this arrow, and that means yields. So the reactants yield products. Just like if you're making a cake, you have flour and sugar and butter and eggs and whatever yield a cake. Okay, so the idea behind balancing chemical reactions is that you have specific ratio of amounts. And by amounts, I mean moles or molecules of every species that you're talking about. So it's all a ratio of amounts. So here we have CH4 and O2 yield CO2 and H2O. Okay? But we need to figure out the ratio because right now, so the numbers in front, we're going to be putting numbers in front here. Okay? And the numbers in front signify the ratios. Now, in chemistry, as you know, if there's no number, we assume it's a 1. So right now, it seems like one CH4 will react with one O2 to produce one CO2 and one H2O. But that's because we haven't balanced it yet. So we're going to need to balance it. Now, you want to, this is all about conservation of mass, so you want to have the same number of carbon atoms on one side, for example, as you have of carbon atoms on the other side. And by side, I mean side of the arrow, so left side or right side. So how many carbons do we have? Well, I see one here and one here. It always works best to start with the least complicated element. It'll all work out in the end no matter what you do, but because there's so many O's here, there's an O there, there's an O there, and there's an O there, I'm not going to start with that because that's kind of complicated. So I'll start with C. Again, there's one C there and one C there. Okay, how do I know? Because remember, there's invisible subscripts, one there and there. Okay, so my carbons are balanced. Now I'm going to look at the H's. There's 4 on the left side and there's 2 on the right side. So in order to get my H's balanced, I need to put a 2 in front of the H there. So now as you can see, 2 times 2 makes 4 on the right, and we have 4 on the left. So now look at our oxygens. For our oxygens, we have 2 times 1 makes 2 on the right plus this other 2. So we really have 2 plus 2 makes 4 on the right, and we only have 2 on the left. So because we have 4 on the right and we need 4 on the left, we're going to put a 2 in front of that O2. So now 2 times 2 makes 4 on the left side, so now we have 2, and 2 more makes 4 on the right side. So now our oxygens are balanced. Okay, so these numbers in front, there's an invisible 1 here, there's a 2 there, there's a 1 there, and a 2 there. They're called the stoichiometric, it's a big word, stoichiometric coefficients. Okay, these are the numbers in front. Whether it's a 1, which is still a number, or a 2, or any other number. Okay, these are called the stoichiometric coefficients, and they represent either the number of moles or molecules. So I'll show you an example by what I mean by that. So how this ratio works for this reaction is that 1 mole of CH4 reacts with 2 moles of O2 to produce 1 mole of CO2 and 2 moles of H2O. So that's using the word moles. That's one way to interpret this. The other way, okay, which is the same ratio idea, is with molecules. So you could say 1 molecule of CH4 reacts with 2 molecules of O2 to produce 1 molecule of CO2 and 2 molecules of H2O. Okay, so now we're going to do some practice. So chemists, as promised, we're going to do some practice. Okay, so let's get a blank sheet here. Okay, so let's do some example problems. We'll call this one number 1. Okay, this will be magnesium plus HCl, hydrochloric acid, yields H2 and MgCl2. Okay, so the idea, remember, is conservation of mass. So we need the same number of atoms of each element on one side of the reaction, on the left side, and on the other side, on the right side. Okay, so you're going to want to balance that one. I'm going to write the rest out. Okay, you can copy these down on your papers and try them out. Here we have N2 plus H2 yields NH3. And for a third one, we have K plus H2O yields KOH plus H2. Okay, so here are some practice problems. You're trying to balance these out and write this on a separate sheet of paper and do it out. Feel free to pause this because I'm going to start doing the answers. So pause this now and then you can check your answers and we can move on. Great, well I hope that went well for you. So for the first one, okay, we've got magnesium on one side with HCl, and on the other side we have H2 and MgCl2. So I see one magnesium and one magnesium. Great, that seems to be balanced. Now on the left side I see one Cl, and on the right side I see 2. So in order to balance it out, we're going to have to put a 2 in front there. So now on the left side I've got 2 H's, and on the right side I've got 2 H's. And that's great. That's balanced. Okay, if you did it in a different order, that's okay, as long as you end up with this, a 2 in front of HCl and 1's in front of everything else. So this reads 1 mole of Mg reacts with 2 moles of HCl to produce 1 mole of H2 and 1 mole of MgCl2. Also, 1 molecule of Mg reacts with 2 molecules of HCl to produce 1 molecule of H2 and 1 molecule of MgCl2. Okay, so let's look at the next one. Okay, to balance it out, I've got 2 N's here, and I've only got 1 there, so I'm going to put a 2 in front of the NH3, and then that gives me 6 H's on the right. Okay, 3 times 2 makes 6, so because I have 2 on the left, I'm going to put a 3 in front of that H2 to make 6 H's on the left. And let me just double check the N's at the end, so now we still have 2 N's and we still have 2 N's. Okay, good. And for the third one, I see we have 1K and 1K. That looks to be good. I see 1O and 1O. That looks to be good. Now I'm going to deal with the H's. I dealt with them last because they exist in so many places, right? They exist everywhere, so I just want to deal with them last. So in order to do the H's, well, I've got 2 there, and 1 there makes 3 on the right side, and I only have 2 on the left side. So it's always tricky whenever there's something that exists once, when on the other side it exists twice. I can only have even numbers. If I put a 2 in front of the H2 here, I'll get 4 H's. If I put a 3 in front, I'll get 6 H's. If I put a 4 in front, I get 8. Notice those are all even numbers. So I want to make this an even number on this side. So in order to make it an even number, if I put a 2 in front of this, now let's count the H's on the right. I've got 2 here, and 2 there makes 4. Well, how can I make this 4? If I put a 2 there, that'll give us 4 H's on the left. Again, very nice to know left and right in this situation. Okay, so I've got 4 H's on the left, and 2 and 2 makes 4 on the right. Okay, now, well, I kind of messed up my O's, or did I? I've got 2 times 1 makes 2 on the right, and I've got 2 times 1 makes 2 on the left. Okay, so I didn't mess them up. That's good. Now I've got two K's on the right, and I only have one K on the left. So I'll put a 2 in front of that K, and that gives me now two K's on the left. So I can check them all through again. They're all balanced, and there are your answers. So great job, chemists. Now we have something that takes our balancing reaction equations to the next level. So here I have the first reaction that I gave you in this lesson. Okay, so the first step is to balance it, and we're going to do stoichiometry. I forgot to mention that giant word up there. Okay, stoichiometry. Stoichiometry is the study of the ratio of amounts. So we're going to use this example equation here for an example problem to work with this. So the first step is always to balance. Always, always, always balance. That's why we just learned it. So to balance this, hopefully you might know, you can try to work on it with me. Pause it right now if you want to balance it. Okay, so you'd put a 2 in front of the O2 and a 2 in front of the H2O. We also did that earlier, so you might have your answers down already. So it's 1 CH4 plus 2 O2 yields 1 CO2 plus 2 H2O. Okay, so now if I said you have 48 grams of CH4. You have 48 grams of CH4 that react. How do I know they react? Well, because they're on the left side, so they are reactants. Okay, 48 grams of CH4 react. I want to know how many grams of H2O can be produced. I put question mark G, meaning how many grams of H2O can be produced. How do I know it's produced? Because it's on the product side. It's on the right side of the reaction equation. Okay, so let's figure that out, and that is the idea behind stoichiometry. So this sort of like conversion factors, we're going to have a bunch of lines drawn out with multiplication signs. Okay, 48 grams of CH4. Okay, well, we can go from grams to moles. Now remember, the numbers in front, these stoichiometric coefficients, represent how many moles you have. So 1 mole of CH4 reacts with 2 moles of O2 to yield 1 mole of CO2 and 2 moles of H2O. We're going to use that to get from CH4 to H2O. That is the only way to convert from one species to another. Okay, a molecule of CH4 to a molecule of H2O. The only way to convert from one to the other is in moles. So we've got to get from grams to moles. Okay, hopefully you know getting from grams to moles, you use the molar mass. So the molar mass of CH4 I get from the periodic table, and it's 16.05 grams per 1 mole. I wrote it that way so that the grams will cancel out. Okay? Now I'm in moles of CH4. I'm going to write CH4 here just to remind myself that we're talking about CH4. So now I'm in moles of CH4. So you can convert from moles of CH4 to moles of H2O using our stoichiometric coefficients, our numbers in front. Okay? Those are your mole ratios. So I want moles of CH4 on the bottom because I want them to cross out, and I want moles of H2O on the top. Okay? So what are our numbers in front? Well, our mole ratios, we have 1 mole of CH4 reacts to produce 2 moles of H2O. Again, where did that come from? Right there, and the invisible one right there. Okay, so those are our mole ratios. Okay, they come from our stoichiometric coefficients. So again, the ratio is 2 to 1 from H2O to CH4. Okay, so I'm going to cross out my units there, and I'm in moles of H2O. Do I want to be in moles? Nope, I want to be in grams. So to convert from moles to grams, I'll put moles on the bottom, grams on the top. Now we're talking about H2O. So we got to use the molar mass of H2O, and that from the periodic table is 18.02 grams per 1 mole. So now we've got grams of H2O. That's exactly what we wanted to get to. So I do out the math, and I should get about 110 grams of H2O. Okay, so with 2 sig figs, remember there's 2 sig figs there, so I want 2 sig figs there. Okay, so I should get 110 grams I think on my calculator I got about 108 or something like that, but I should get 110 grams of H2O. So that's how much H2O can be produced from 48 grams of CH4. So chemists, here is a pretty helpful thing I think to have in your notes. It's one of my famous little road maps. Okay, so this will help you get between units of any molecule or ionic compound that you're talking about in a balanced reaction equation. Okay, so again, remember in a balanced reaction like we just had, to go from moles of one thing being A, like that could be the CH4 and B would be the H2O, right? So A and B are just different molecules. So to go from one molecule to the other, you have to be in moles. Notice, that's how I get from the pink side to the blue side, or the blue side to the pink side. Okay, again, so you have to be in moles. That's where your mole ratio comes from, okay, to go from one molecule to another. And then when you have moles of one thing, you can go from grams. How do you do that? Using molar mass. How do you go from grams to milliliters? Hopefully you remember that. That's density. How do you go from moles to molecules? That's Avogadro's number. Okay, I'll write some of these things down. So the same thing on the other side. How do you go from moles to grams? That's molar mass. How do you go from grams to milliliters? That's your density. How do you go from moles to molecules? That's Avogadro's number. Right? And then from moles of A to moles of B, this is from your mole ratios. This is from your balanced equation. Okay, always got to have a balanced equation, so that is the first step. Okay, so we're going to do one more example problem. Great, so one more example problem. Here we have, let's see, we'll do C6H12O6 plus O2 yields CO2 and H2O. Okay, hopefully you recognize this from biology class. This would be cellular respiration, where we're breaking down the glucose molecule. Okay, so first, hopefully you know what to do first. First you're going to balance it, okay, and then I'm going to tell you, you have 1.26 times 10 to the third, 1.26 times 10 to the third grams of CO2. Okay, you've got 1.26 times 10 to the third grams of CO2 that you're producing. I want to know, in order to produce that, how many grams of glucose of C6H12O6 needs to react to produce this many grams of CO2. So you're going to start with CO2 and try to get to C6H12O6. Okay, so you can pause it now, and good luck. Okay, chemists, here's the solution for you to this problem. So, hopefully you've all gotten the first step is to balance out. So we need a 6 there, a 6 there, and a 6 there. Maybe you memorized that from bio. 1666 is your balanced equation. So that's first, and then you're going to start with what you have. Okay, we've only got one number down here. Okay, this is how much CO2 we have. 1.26 times 10 to the third grams. I'm going to write CO2 so I know what I'm talking about. Okay, it's part of the labeling. Now, I want to get from CO2 to C6H12O6. So the only way to get from one thing to the next is using moles. So I got to get from grams to moles. Okay, hopefully you got the molar mass of CO2 is 44. Okay, it's 44.01. I'm just going to write 44. Okay, grams cancel out. So now, again, I'm going to keep labeling. This is moles of CO2. So I want to convert to C6H12O6. So I'll put moles of CO2 on the bottom and moles of C6H12O6 on the top. And now here's your mole ratios. If you didn't balance it, it'd be all ones. So you should know you're doing something wrong if it's all ones, potentially. So moles of CO2, 6 there and 1 there. Okay, and now you've got moles. I'm going to have to come down here because I'm running out of room. So now I'm in moles of C6H12O6, and I want to get to grams. Hopefully you figured out it's about 180 grams in 1 mole of glucose. So you do that out, moles cancels out, and we're left with grams of glucose. And the answer is 859 grams of glucose. C6H12O6. And there's your answer. 3 sig figs in the answer because I have 3 sig figs in the problem. Your mole ratios are exact. This 1 to 6 here, these are exact, so they do not count in the mole ratios. Okay, so hopefully you got that, 859 or something around there, if you use decimal places on your molar masses. So that might make it a little bit different, but about that. So congratulations, and we'll see you in class.